We've looked at polyatomic ions before. Now we're going to draw their Lewis structures and get into a little more detail on them. So we'll start with a nice simple one, ammonium, which is NH4 1 plus. That 1 plus tells us it's got one more proton than electron, and that occurs because it lost an electron. So nitrogen has 5 valence electrons, hydrogen has 1, and there's 4 of those, which is 4. That's 9 electrons total, but we're short 1 because we have a 1 plus, so that tells us we have 8 valence electrons to place. As per usual, we start with nitrogen in the center, and we'll place our hydrogens around it. There are no other options. That is our 8 valence electrons. This whole thing has a positive 1 charge. There's ammonium. There's not a lot going on there. We don't have to worry about multiple shapes, but we'll look at a couple where maybe a couple different shapes are possible. And while we're on that, we do have electrons in 4 different groups, but they're all single bonds. So this is tetrahedral electron geometry. It is also tetrahedral molecular geometry. So that shape has a tetrahedral. Then we have cyanide, Cn1-. Now carbon has 4 valence electrons, nitrogen has 5 valence electrons, and a 1- means we have 1 extra electron. So that's 10 valence electrons. So we can start with carbon and nitrogen and our single bond. And then we generally place our electrons around the more electronegative atom. And that's all of them. We need 10 for this total. We have 2, 4, 6, 8, 10. But clearly not everything's obeying the octet rule. 2, 4, 6, 8, 10. I need another pair of electrons over here. So what we can do is slide these electrons over. And so we'll see that that's actually a triple bond. Carbon, triple bonded to nitrogen. And there we have it, and we have 2, 4, 6, 8, 10 valence electrons just like we're supposed to. Again, this doesn't have any other shapes, but it does have a 1- charge. So we put our brackets and we put our charge. Now chlorite, Cl, 7 valence electrons. O2, oxygen of course has 6 valence electrons. There's 2 of those, that's 12, and 7 is 19, but there's an extra, so plus 1 is 20 electrons to place. So we'll start with oxygen, we'll single bond it to another oxygen, and we'll single bond that to a chlorine, and then we'll start placing our electrons. We have 20 total, there's 2 4, so we have 16 left to place, so 2, 4, 6, 8, 10, 12, 14, 16. Make sure we did that right. 2, 4, 6, 8, 2, 4, 6, 8, and that's 16, 18, 20. Those are all single bonds. There's nothing else we can do with that. There's our ion. Now, it wouldn't change anything if you just went ahead and rotated that and you had your chlorine over here and your other oxygen over here. It'd still be the same structure. This is tetrahedral geometry on the central atom and electron geometry, but there's 2 lone pairs, which is going to push that thing down into a bent shape. So that's a bent molecule. A couple more examples. NO2 1-, nitrite. So nitrogen, oxygen, oxygen. And then we have 5 plus 6 plus 6 plus 1 for our 1 extra electron, which is 18 valence electrons. So we'll start 2, 4, 6, 8, right, 10, 12, 14, 16, 18 valence electrons. Okay, well, if we look at that, oxygen's obeying the octet rule. Oxygen's obeying the octet rule, but nitrogen is not obeying the octet rule. We need to slide one of these pairs of electrons over to make a double bond, and it doesn't matter which one we pick. We could double bond to the left, and we could do this, and then we'd have this molecule, or we could have done it the other way and put our double bond over here. Now, this is one way of drawing this molecule. It's a 1-, but because there's multiple different shapes that this thing could have, it's actually got what we call resonant structures, and both of these exist. And so we draw the other one, and we have oxygen single bonded to nitrogen, double bonded to oxygen, and then we have this shape. Now, this one's pretty straightforward. It also has our 1- charge. Those are resonant structures. And as you can see, we would have, let's see, we got 3 electron groups, but this will be bent because we do have a lone pair on our central atom. And then nitrate, NO3 1-, so this has got another oxygen in it, so we've got our 5 valence electrons, then 18 more, and then 1 more, which gets us 24 valence electrons, so nitrogen, oxygen, 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 and then that's 2, 4, 6 of our 24, so we have 18 left to place, so 2, 4, 6, 8, 10, 12, 14, 16, 18. And again, we run into the problem where we have 24 valence electrons, we've placed them all, but nitrogen doesn't have its octet full. So again, we can slide any one of these pairs of electrons over and make that double bond with nitrogen. We could do it here, or we could do it on the left one, or we could do it on the right one. And this one is a little bit more important of a resonance structure because they are actually different depending on where that double bond is drawn. So again, we're going to have 3 resonance structures with this one. So we can put the double bond on the side, either side, or we can put that double bond down below. So you have to draw all of the possible shapes, all of the resonance structures with this thing, and there are 3 for nitrate. They're all 1-. It's just a matter of where you're actually putting that double bond. So these are resonant structures. There are 3 of them for this one.